Okay, so we're looking at differentiating exponentials. We're looking at these three types. So e to the x here, and things like e to the 2x, 2e to the 3x, and differentiating those. Similarly, we have a to the x, so these are exponentials which aren't e, and what we can do to differentiate them. And finally, we're going to look at ln x and how we can differentiate ln x functions. First thing to do is look at the graph of e to the x. So here's our graph of e to the x, and I've got a point on it here and a tangent, so I'm showing what the gradient is doing. So down here, when we are negative, we have pretty much a zero gradient, and as I work up, I get through a gradient of 1, and I get steeper and steeper and steeper. Now, if I was to find what the gradient was here, what I can do is I could plot the gradient function. Okay, and a few things to point out. When we're at 0 here, so 0, 1, the gradient is 1. When we're at 1, the gradient is 2.72, which is very close to the number e. So actually what we see is that the gradient function takes on the same value of the graph at that point. So what I mean by that is if I'm to plot the gradient function, the gradient along here, the graph I'll get is this. I'll get exactly the same graph. Okay, so the derivative of e to the x is the same graph as e to the x. If I start with f of x equals e to the x, when I differentiate it, because of the graph I just showed you, you get e to the x, you get the same graph. And this forms the basis of all the work we're going to do with differentiating e to the x. You start by writing the same function. Now there might be some extra stuff to put on, but you're always going to have the same function at the root of it all. So for example, if I have f of x is e to the 2x, then when I differentiate it, I'm going to start by writing e to the 2x. In this case, because 2x, when I differentiate it, gives me 2, I multiply my function by 2, so I get 2e to the 2x. Another example, if I have 2e to the 3x, well then the first thing I do is I write e to the 3x. Then I think about differentiating the power. So the power is going to become 3. 3 times 2 is 6. So I get 6e to the 3x. How about if I have f of x is e to the 2x minus e to the x? Well, in this case, I just do them individually. So the first one becomes 2e to the 2x minus e to the x. If I bung in some negatives, so if I have e to the minus 2x, when I differentiate this, I get e to the minus 2x times minus 2. Okay, finally, don't be caught out if I have e to the minus x, it's going to become minus e to the minus x. And I can see this on this graph here. My function is e to the minus x, and if I differentiate it, I get minus e to the minus x. So as we can see, the gradient function is negative because we have flipped over the graph. Okay, so the graph becomes goes from a negative gradient to a zero gradient. Therefore, the graph must go down here. Okay, so what happens if I want to differentiate ln x? Okay, f of x equals ln x. Let's look at the graph. So I start with the graph of ln x here. Okay, remember it's a logarithm, can't go negative in this direction. Now, if I treat this in the same way, I put a point on the line, make a tangent, find the slope, and then I plot those. If I turn the trace on here, to show trace, okay. and I move this point around, you'll see the graph that I produce. So what I'm doing here is I'm making or showing the gradient function of this ln x curve. So it might look familiar. The graph that I'm drawing, hopefully you can see, is the graph of 1 over x. Now, clearly we only have half of this graph because we can't go negative with the ln, so this sort of left-hand side is a bit irrelevant. But on this side, the 1 over x is the same as the derivative I've just found. Okay, so going back here, if I differentiate ln x, I get 1 over x. Okay, and you just need to learn this. We get 1 over x when we differentiate ln. Okay, so a couple of examples for you. If I have ln 3x, let's think about this. Now, you may be tempted to say, right, well, I'll just do 1 over x, then times it by 3. But actually, thinking about our laws of logs, we need to be a little bit sort of more forward thinking in this. So we need to change this into ln 3 plus ln x. We split them up. Remember your laws of logs, ln AB equals ln A plus ln B. So we differentiate them individually. So the differential of this, ln 3 becomes, well, 0, okay, because it's just a number, and ln x becomes 1 over 3. Sorry, 1 over x. So similarly, if I have f of x equals ln 4x, or I have f of x equals ln 5x, they're going to get the same treatment. They're going to become 1 over x. Well, okay, what if I have f of x equals 3 ln x instead of ln 3x? Well, in this case, when I differentiate, ln x becomes 1 over x, and 3 stays where it is. So I get 3 over x. Okay, so a slightly different situation. Another example. F of x equals ln x squared. Okay, well actually this is quite similar to the last one. If I have ln x squared, I can rewrite this as 2 ln x. Remember your laws of logs. Then if I differentiate it, I get ln x becomes 1 over x times 2, 2 over x. Okay, I'll do one more example for you. If I have f of x and f of x equals ln x squared plus ln 2x cubed, then I need to sort of break this down to start with and rewrite it. So f of x, I'm going to write 2 ln x, ln 2x cubed, or I'm going to write ln 2 plus 3 ln x. Hopefully you can see where that's come from, because ln x cubed becomes 3 ln x. If I simplify this, I have 5 ln x plus ln 2. And then finally, differentiating isn't too taxing. Ln x becomes 1 over x, so this becomes 5 over x. Ln 2 becomes 0, so I'm left with 5 over x. Okay, the last thing to think about is if I have a graph like 2 to the x, or 3 to the x, or 4 to the x. Remember that if we have e to the x, that's e to the minus x. E to the x is here. This is 2 to the x, so it's slightly below e to the x. And unless you're on this blue line, you get treated slightly differently to e to the x. E to the x is unique in that it differentiates to itself and integrates to itself. So if I take away e to the x, I've got 2 to the x. Now again, if I use my method to find the gradient function, and I plot my point, so if I drag this one around, what you notice is you get an exponential graph. So there's nothing sort of wildly different, but we get an exponential graph, and I'll show you algebraically, but I'll show you it here now. The graph that gives this line is 2 to the x ln 2. Okay, if I shake this, there it is. And 2 to the x ln 2 is this differential, okay, it's the gradient function. So where does that come from? Where does 2 to the x ln 2 come from? So we start with f of x equals 2 to the x. And this is a very difficult thing to try and differentiate, because you're thinking, well, if it was the other way around, x squared, this is easy, yeah? You times by that power, you reduce the power by 1. But that's not what we've got. We've got 2 to the x. So it's a little bit tricky. And actually, there's a little trick to it. And what you do is you express 2 to the x in luns. You say I've got e to the ln 2 to the x. Now remember that e and ln are kind of different. So for example, e to the ln x equals x. These kind of cancel each other out. But by having e to the power of ln 2 to the power of x, it allows me to differentiate. So what I do is I differentiate, which means I say, well, I have e to the ln 2 to the x to start with, times by this bit differentiated. Now, what I do is I rewrite this slightly. I say I've got e to the x ln 2. And by chain rule, if I differentiate x ln 2, because ln 2 is just a number and x is our variable, I end up with ln 2 when I differentiate. Okay, so I get e to the ln 2 to the x times by ln 2. Now e to the ln 2 to the x is just 2 to the x. We've established that to start with. That was our first move. So I have 2 to the x times by the differential of the power, ln 2. Now, you can just sort of follow this as a rule. You can say f of x of, for example, a to the x is going to differentiate to a to the x ln a, and that's fine. And remember that, remember you can do that, but remember how you get there. So this method here is really, really important. Now you might be thinking, well, why doesn't it work for e to the x? Well, actually it does work for e to the x, and I'll show you. If I put e to the x in here, I would say I have f of x is e to the x, and if I just sort of plug it in, I get f dashed x equals e to the x ln e. Now ln e equals 1, so we don't write it. It just equals e to the x, okay? Whereas otherwise ln a isn't 1, so we had to keep it in there. In this case, ln 2, like that. Okay, so some examples of questions like this. Well, let's have a think. So, for example, if I have f of x equals 2 to the 3x, for example, and I want to work this one through, well, I rewrite it. I use this method again, so I'm going to write e to the ln 2 to the 3x. I'm going to rewrite this as e to the 3x ln 2. And now, when I differentiate it, I get e to the 3x ln 2 multiplied by this differentiated. Now this differentiated, I could sort of rewrite this as 3 ln 2 times x. So the x disappears and I'm left with 3 ln 2. 3 ln 2, by the way, is the same as ln 2 cubed, or ln 8. So this part stays the same. This is 2 to the 3x times by ln 8. Now, you can do this even quicker. You could say, okay, I've got f of x equals, I don't know, let's just add a power, so 2 to the 4x. Well, when I differentiate this, this is going to be 2 to the 4x times by ln 2 to the 4. And if you want to get rid of that power, you can say it's 2 to the 4x times by ln 16. Okay, and they follow quite a nice pattern. You can sort of have a play with them and see how you get on. Okay, last example. If I have f of x equals 8 to the x plus 4 to the 2x. These are very different, they've got different base numbers, so what I'm going to do is I'm going to change their base. So 2 squared all to the power of x plus, sorry, I'll change that. So 2 cubed to the power of x plus 2 squared to the power of 3x. This gives me 2 to the 3x plus 2 to the 6x. So when I differentiate this, I get 2 to the 3x ln 8, and I get 2 to the 6x ln 2 to the power of 6, which is 64. Okay? So you change the base and then apply that method to them. So you can differentiate e to the x, you can differentiate ln x, and you can differentiate a to the x, which kind of lies in between these two in a sort of compound method. Okay, practice this a lot, make sure you get comfortable with it, and always remember which way ln x goes. So ln x differentiates to 1 over x, not the other way around. A lot of people get confused with which way around it goes, but yeah, make sure you're happy with it. Okay, good luck and have fun.